And again, I hope that Mr. Abi will be able to give us some briefs from the start so that the flow will actually be, so that it will enhance the flow. It shouldn't start from middle of somewhere that the flow might actually have been disrupted. Hope you can understand me.
Yes.
I'll kindly appreciate that. Thank you so much. So, okay.
So can we all see this? Can we all see my screen now?
Yes, we can.
Okay. Yeah, it's system now. I'm waiting for my system anyway. I'm sorry for that.
So before the presenter is actually fully ready, I would actually want to interact with every one of us. Please, let's kindly make sure that we actually maximize this time to learn a lot of things. And again, we want to, like, we hope that you don't find our earlier session somehow, because it was due to some issues that we had to actually work on, and everything is fully settled now. And like you said, we are having 4 presentations today, which are involved in things that are highly beneficial and related to people. So, like, we've known that a conference is actually meant to be educative. We are not going to a conference to go and play. A conference is for you to come and learn actually. So most time when people go for conferences in a business, in a brand, in a company, they even sleep over. Sometimes they do conference. Sometimes they even set conference in the night, showing how conferences are usually very, very dedicated. So we should make sure that this weekend is, we can't say we are doing it next week. So it means that this is the weekend and this is a chance for you to learn all these things. So you have to maximize it and make sure you reach out to other people that you know that they might benefit from this. These are things that, like I've said before, they take a lot of things to actually learn, and it's coming for you for free. And with us dedicating our efforts and our funds in making sure that we provide exclusive free necessary things that the community needs. So I hope you actually take a lot of your time to make sure that you maximize it to learn. So the presenter is ready, so I think we can start.
I'm still working on my system.
Okay. Yeah, we can see that.
So before the system actually finish resetting, who can actually brief us on what was discussed earlier? Who is actually here that quite remembered and can brief us on what had been discussed earlier? So it means most of us here were not in the morning session. Okay, I think anyone, this might actually call for the presenter to actually brief us from the start again, since no one is able to say anything here. No one knows the concept of artificial intelligence. I know that there are some people here that are involved in AI already. You should actually be able to brief us on that.
Yeah, I think what hello,
I can
Yeah.
hear
please
you.
can you hear me?
Yes, you're
Okay, good
Yes.
audible.
morning.
Yeah, we
So
can.
from what I could remember, I think it talked about artificial intelligence. It talked about computer vision. It made mention of sensors. How and it made comparison with human being, human senses in comparison with computer sensor. And I think he also made mention of um, artificial intelligence in agriculture, talking about irrigation system and some other things like that.
Another thing. So yes, you're on the track. You actually are on the track. So um okay, who can actually state a two projects that the presenter said he was on during the first class? Any two projects, that is the application of all this artificial intelligence. He mentioned about 4 or 5 projects during his talks. So
Actually, from my own
actually,
view,
from now,
artificial,
I think that
artificial intelligence,
artificial
it's
intelligence
it
it's
mainly consists of
mainly
four
consists of
parts.
4
We have
parts.
the machine
We have
learning
the
part,
machine
the
learning part,
computer
the
vision,
computer
the
vision,
natural language
the natural
processing,
language
and
processing, and
deep learning.
deep learning. Okay, thank you so much. So, Mr. Abi, please kindly start, and um, I hope that this will go very well, and I hope that we'll be able to learn a lot from it. Thank you so much, Mr. Abi. We are waiting for you.
Okay, so
Okay, so
though
though you can
you can
unmute
mute yourself so
you can
that
mute
there will
yourself
not
so
be
that
echo.
there will not be echo.
Okay, I think I'm still on it. Okay, yeah. The before my system was it will be able to give me a better result. First, let me give a general overview of what you have been doing because the talk is all about artificial intelligence, machine learning, robotics, and what is called hybrid vehicles. So, but before we look at hybrid vehicle itself, because what we mean by hybrid vehicle is the combination of autonomous vehicle and electric vehicle. But before we look into that, we need to understand artificial intelligence itself, the role of machine learning before we can now say, okay, how can we now transfer this knowledge to understand self-driving cars? So I started with a definition of artificial intelligence itself, which simply means that um, you are trying to mimic a human through machine. That is taking the brain of a computer, then put it on a machine. So that is what AI is all about. Okay. So now looking at the broad of AI, because we are talking about trying to mimic human behavior, then it simply means that there should be a channel to see and recognize. There should be a channel to listen and speak. There should be a channel to analyze and learn. So looking at all this, then it has to do with the three aspects of artificial intelligence. So now, I'm not trying to explain why do we need artificial intelligence, because some people believe that people that they are in sciences actually need artificial intelligence, but the answer is no. Everyone need artificial intelligence. So now, why do we need artificial intelligence? Number one, just to automate a repetitive learning and discovery through data. That is, it should be able to get some prediction, some discovery through the data that have been supplied to the machine. Also, artificial intelligence add to what is called add intelligence, because there is an aspect of automation, because I've already explained what is meant by industry 1.0, 2.0, 3.0, and 4.0. So, but I would like to do a simple recaps on that. So we are talking about Industry 1.0 it have to do with human doing the work. Then Industry 2.0 have to deals with the combination of both human and machine, but not up to some efficiency. So that's why we now have Industry 3.0 that have to do with autonomous and something automation. Let me call it automation. So I was not giving an example of you can have what is called GSM based home automation, you can have Bluetooth control home automation, in which you are in somewhere, then you send a message to the appliances, then it gives some response to the message being sent to the appliances. So, but looking at that, we still need some aspect called intelligence. So that is where we now have Industry 4.0, which starts from year 2015. So looking at that, we have a lot of digital trends in Industry 4.0, which include artificial intelligence, which include blockchain technology, which include brain computing interface and the rest. So now, taking this artificial intelligence, then trying it to apply it to what we have automatic system, then it makes the system to be more robust. So which means that it add intelligence to the system. Okay. Now the next one is that it AI analyze more and deeper data. That is, AI achieve incredible accuracy. And also AI can work for 24/7. So I already cited an example of an hospital. That is, you go there and the doctor was not able to attend to you. So but with AI, with a machine, then that one have to is not part of it. Also, it reduces manpower. Instead of you doing a lot of work by yourself, then you have artificial intelligence based machine that can do the work. Okay, so there is this quote that I want you to take note of it. And the quote is: Sussex in creating AI will be the biggest event in human history. Unfortunately, it might also be the last unless we learn to avoid this risk. Okay, please, I'm coming. I'm sorry for that. Okay, so we can look at the aspect of AI, which include ability of a computer to see and recognize, which is computer vision and deep learning. That is, human have eye, then a machine can have camera that can serve as eye. Then the second one is ability to sense and analyze. So that one have to do with machine learning. So and that one have to do with sensing organs, which include sensor. So I cited an example earlier that looking at irrigation system, I just want a machine that can water the plants. So in this case, I can have AI based machine that have all these sensor like ultrasonic sensor to check the water level of the tank. I can have water level sensor to check if the soil need to be wet. So with artificial intelligence and an aspect called machine learning, which is a subset of artificial intelligence, then it make it more easy. And the last aspect is listen and speak, that is natural language processing. So I actually urge people that they are in art and humanities to also key in into this role of artificial intelligence, because it have to do with, there are a lot of projects that you can do under natural language processing, which include fake news detection. You can use it to detect fake news and the rest. So that is how we come across AI. Okay. So now, what are the applications of AI? So the applications of AI, we can apply AI in medical, and applying it in medical, we have what is called AI doctor, which is a kind of machine that analyzes the symptoms and causes and suggesting the medicine for the patient. So those knowledge is fed by tons by medical data based on the application. So in this AI doctor, Oilsplick also have a project that we'll be working on AI doctor. Also for physical applications for handicap. Like I said earlier that we are going to have another presentation on advanced technology, brain computing interface. So we also We are going to look at how AI plays major role in BCI. But if you are talking about the application of this, people that they are paralyzed or they are physically challenged. So instead of them to be doing all this work, then there can be a machine that can be doing it. Also, we can also use AI to predict disease from medical image. So if there is time, I'm going to show you some of the work that has been done on this. And lastly, voice recognition for ALS patients, that is asthmatropic lateral sclerosis. So we are going to also artificial intelligence have application in agriculture, which include to analyze the weather and to forecast the weather to give vegetation suggestion based on crops in a field. And also, this application can now monitor the crops 24/7 to detect the disease using image processing and to spray the suitable pesticide. Now, let me explain that. We can have a machine, it can be attached to a drone. What do you mean by drone? Unmanned aerial vehicle. So once the machine has been attached to this drone, it move up, start checking if the crop need pesticide. Then if it need it, it started spraying it. So this can work 24/7. So these are the area that AI plays a lot of role in agriculture. And also, after cultivation, fruit and vegetable needed to be segregated. So I was now citing an example of you have AI-based robotic that was able to determine ripe fruits and unripe fruits. So the robot or the machine can be able to pluck if the fruit is ripe, and if the fruit is unripe, then it's going to leave it like that. So these are the application of AI. And also, we have heard about Alexa, Siri, and Google Assistants. So with this, for an instance, we have person that is blind. So there are some things that he cannot do at home, but with an application which falls under this AI voice assistant, he can control it with sound. And for people that want to join the tutorial section, we have an aspect on embedded system that you are going to learn with this embedded system and Internet of Things. So with this, you are going to do experiments, different experiments on this. So AI also plays major role in search engine. So in form of Google suggestion, you search for wristwatch today, then tomorrow is giving you some prediction. That is, it can give you prediction of clothes, something like that. So Google suggestion, AI is the one playing the major role. So AI play major role in an aspect of digital marketing called search engine optimization, and AI plays a major role in results and also in web ads. So that is the AI role in search engine. So AI in social media. So we can use AI in social media to analyze user interest in several topics. So if I know the kind of information that you want, then I can start giving you suggestion on it. So AI can play that role. It can also be used in e-commerce to analyze the user need and to recommend the product. I know some of us have experienced this. When you go to AliExpress, you order for wristwatch, then the next thing is that it started giving you some prompt on clothes or started giving you some prompt on t-shirt. So it simply means that it's giving you some suggestion based on your what you are having. Okay, so AI in autonomous vehicle, and we are still going to look at that in details. We are still going to look at that because the topic is about artificial intelligence, is about robotics, and is about hybrid vehicle. So we are still going to look at autonomous vehicle. So on this note, we are through with the first chapter, and I want each and every one of us that have questions to just write it down. So maybe during the question time, we can still explain more. So now, before we now look at electric vehicle, we need to know the history of automobile itself. Then I want you to pay attention to those pictures because I will not explain more. Now, in 1885, that was when we have the first commercial gas car by Benz patent motor engine. So that is the car as you are seeing it. So in 1908, we have the first mass-produced car. Then in 1911, we have the electric starter. In 1939, we have the hydromatic drive being and in 1958, we have the modern cruise control. So you can see the evolution of what? Of automobiles. Then in 1971, we have the anti-lock braking system. And in 1981, we have the first ECU. And in 1996, we have the first connected car. And in 2000, we have the lane departure warning system. Okay, so in short, these are the history of automobiles. In 18th century, we have what is called steam vehicle. So in 19th century, we have combustion vehicle, and in 20th century, we have gasoline and diesel vehicle. And in 21st century, which we have now, we have what is called electrical vehicle. That is, you don't need gas, you don't need diesel for you to power on your car. How is it possible? Then you are going to see on my slide. Okay, there are some companies that have been working on this. We have Google as a company that is working on that. And also at Oilslick, we are also working on the model of autonomous vehicle and electric vehicle. Okay, let's look at the introduction of EV. Okay, EV are conventional vehicles. Okay, anytime we heard about electric vehicle or hybrid vehicle, what should comes to our mind is that the vehicle is supposed to have all these characteristics that I will state later. But I want you to take note of that picture. We have a station, right? We have a connecting wire, then being connected to a car. So that is not gasoline anyway, but the component there, we are still going to discuss about it. Okay, for hybrid electric vehicle, it will have what is called stop system, stop brake energy, regeneration torque assistance during acceleration, and it should be full electric drive. Then it should be autonomous electric drive. This is an electric vehicle, but it have some pros and cons. It have some advantages. So we are going to look at the advantages of electric vehicle and the disadvantages. Okay. Now, number one, for us to even look at electric vehicle itself, we should know that number one is what cost. What do you mean by cost? Low maintenance and simple control. Unlike you have a gasoline powered car, anytime you have to go and visit people that will help you to repair it and the rest. But with electric vehicle, the cost of maintenance is low and it's of what simple control. Secondly, lack of conventional fuel. Option to utilize renewable energy, that is environmental friendly. Unlike gasoline that will produce flames and the rest. So all these things have effects on what is called chlorofluorocarbon. But when you look at electric vehicle, it is what environment friendly because it doesn't release any harmful waste to the environment. And what are the limitation? Charging station. Like if you look at my slide, when you look at this, we already see the charging station. That is, the car must be powered, must be charged on the charging station. Okay. So another limitation is range of distance, and another limitation is the temperature because it's a request for high temperature. Okay. For energy efficiency, less number of conversion. So it requests for less number of power conversion. So we have already know the advantages and the disadvantages of electric vehicle. Now let us look at the components of electric vehicle. So a component of electric vehicle, we have assembly, that is the battery, the power control unit, which is also known as PCU, and the onboard charger. And thirdly, we have the vehicle structure, that is the wheel, the vehicle body, and gear. Let me come back again. For the electric vehicle components, we can have three categories of this. The first one is the vehicle structure itself that contains the wheel. As you can see on my slide, it contains the wheel, the vehicle body, and the gear. And secondly, we have the battery. So for electric vehicle, it must have battery, it must have motor, and it must have what is called power control unit and onboard charger. And lastly, other essential components. So for other essential components can be other components that are attached to the electric vehicle. Okay, let us look at EV parts again. This is the body of the electric vehicle. Then we have the motor. So this is the motor of electric vehicle. So we want each and everyone that is attending this conference that anytime you heard about electric vehicle, you should know that these are the what? The parts of electric vehicle. Then we have what is called inverter. So what is the meaning of this inverter? Inverter is a device that converts alternating current to direct current. Let me go back again. Inverter is a device that converts alternating current to direct current. So what do you mean by alternating current? Alternating current are current that changes sinusoidally with respect to time. So let me give an instance for people that they are not in physics, that they don't come from physics background. We are talking about AC, the current that fluctuates. An example is our NEPA light. An example is power coming from gasoline generator and the rest. So these are example of alternating current. So when you now look at it, electric vehicle is operating based on direct current, that is DC. So you have to convert the AC to DC. So that is why the inverter is coming to play that role. Okay, so we have what is called battery bank. So for the battery bank, this battery bank will contain the battery, and the battery are there to store energies. So when you have more than one battery, then you can call it a what? A battery bank. Okay, so that is that about that. And lastly, we have onboard charger. So this charger will be used to charge the battery. Then the battery is connected to the inverter. The inverter will now convert the alternating current to direct current. So the direct current will be supplied to DC motor. So the DC motor will now move the body of the electric vehicle. Let me come back again. We have the battery bank. So the battery bank is going to have contain the battery that store the energy. So now the onboard charger is to charge the battery. Then from the onboard charger from the battery to the inverter. So the inverter will convert the direct current of the battery to alternating current. Then from the alternating current, it will be fed into the motor. So the motor will drive the body of the car. If you still have any question on that, I can still come back. Then we have the charging station. So the charging station is charging the onboard, is feeding the onboard charger from the onboard charger to the battery bank. So the battery bank is in form of DC. So the inverter will convert the DC, the direct current, that is direct current, then convert it to alternating current. And I've cited example of alternating current. So if you are talking about direct currents, these are currents that do not changes sinusoidally with respect to time. So the inverter will feed in the AC motor, then the motor will drive the body of the car. Okay, so let's look at the block diagram of electric vehicle. We have the person that is driving it, we have the control signal, and we have the motor controller. So if you can check the block diagram, you can see the battery is connected to the what? To the motor controller. Though Oilslick is still going to roll out courses on electric vehicle, and it's going to be an interactive and interesting class in which you will learn about simulation, how to simulate electric vehicle and the rest. So the motor controller is now connected to the motor, and the motor is connected to the vehicle body so that it can power the electric vehicle. Okay, we have the vehicle design procedure. Number one is the propulsion power, the motor size, and the battery capacity. So if you're talking about the battery capacity, just like your power bank that we can rate in form of milliamperes per hour. So that is what we are talking about. Okay, now let us do a little bit of physics. We have a car, two forces being exerted on the tire of the car. The first one is the push force, and the second one is the friction force. If you ask me, why are we bringing physics? Fine. Because for you to understand electric vehicle, or for you to build an electric vehicle, you must understand physics. That is, you must understand the load. You must be able to analyze the load on the electric vehicle. Let me give an instance. You know, when we power on our gasoline generator at home, we do some calculation in the sense that we can say it's actually, if you have full tank, it should be able to serve you for this particular time. Now you are doing all that because you already studied the physics and the mathematics behind it. So the same thing is applicable to electric vehicle. So in this case, we have a car, we have a friction force that opposes the motion, and we have a push force. Now, when we have this, what do you want to bring out from here? Okay, we have what is called aerodynamic drag force. So now we need the power being exerted on this car. So, and what is the formula for this power? Total attractive force multiplied by the velocity of the vehicle. Okay, so now how can we now know the force on the vehicle? Because if you know the force on the vehicle, that is where you'll be able to model your battery. That is where you'll be able to model that for this particular time, my car will spend this time. So that is why we need to understand the physics. But I will not spend more time on this because it's a presentation and it's a general presentation that each and everyone from various departments are coming in. Because you can see how AI is now playing. We are going to explain how AI is playing a role on this. Now, for the forces on the vehicle, we have one rolling resistance force, aerodynamic force, hill climbing force, and acceleration force. When you look at that car as it is climbing up, we need to analyze this so that I will show you why we need it. Because there is an Excel file that I'm going to show you that contain all those data. Okay, for the rolling resistance force, it is one of the force that act towards to oppose the motion. I will just leave it like that. And for people that want to go more in details, Oilslick is ready to help students. Okay, now when you look at this formula stands for aerodynamic drag force. So here we are analyzing the air density, which is in form of kilogram per meter cube. We are analyzing the frontal area, which is in form of meter square, and the drag coefficient. And lastly, the velocity of the vehicle, which is measured in meter per seconds. So that is for aerodynamic drag force. Okay. Now we want to analyze the high hill climbing force. Like I said, the main reason why we are doing this is that for us to have a picture, you can't just do something. You can't say, okay, I have an electric vehicle and it's working. No, you have an electric vehicle. Then you should be able to analyze that, okay, for this also time, this is where the electric vehicle will stop working. So that is what we are trying to look at. So we have this formula to calculate the hill climbing force, mg, that is the mass, the gravity, sine. Theta simply means the angle of inclination. Then the acceleration force. For the acceleration force, we have F equals to mass times acceleration, and for the angular acceleration, we have all this formula to do that for us to calculate that. Now, where do am I putting all this? For you to have electric vehicle simulation, before you start your own design, you must have a simulation. So the simulation can be done on a software called MATLAB. Okay, so now let me now give a general overview of what we are doing. We want to model a car, and we want the ratings of that car to be what? To be 2 watts. To be 2 watts. So what do we need? What are the parameters that we need? We need the weight, the width, the height, rolling resistance, air density. Don't forget that I've already stated the formula. So this formula is what we are going to compute here. For us to have the velocity, you can see the velocity in kilometer per seconds. It has been calculated there. Then the tractive force, which is equals to the rolling resistance force plus the aerodynamic drag force. Though people that are in engineering will find this very, very interesting. So now, let us now give us a sample data of model. All these things that I'm saying, I want to show a sample data. So what is this sample data we are talking about? And that is the end of electric vehicle. Then we can now move to autonomous vehicle. Okay, look at it. The rider mass is very, very important. For this vehicle of 22 watts, I want you to take note. You can see that I put weight, which is in form of what? Mass. Then some of what? The value is 1000 kilogram. Okay, so this there is what is called rider mass. The person that is riding it will have mass. Let's assume it is 80 kilogram. If there is anything wrong in this data, you will not have you will not have the correct result. So the vehicle mass is 237 kilogram. So adding this together will give you the summation of the mass. Then the CGIs, the drag coefficient, the front axle of the tire and the rest. So these are what the sample data of how electric vehicle simulation looks like. Okay. So now we already see how we can deploy all this to have our electric vehicle, right? But let us now look at another interesting aspect, because we are talking about hybrid vehicle. We talk about what? Electric vehicle and autonomous vehicle. Please, am I still audible? Please, I want a
Please,
response.
I want a response.
Hello, are you with me?
So we can hear you.
So we can hear
Okay, thank you.
you. Okay,
So
thank you.
I
So
want all listeners to pay attention to this demo version that I want to show you. Then I want someone to tell me what is happening. What you observe. I want you to just observe it. So just observe what is happening. Can we all see it? You can see the car is moving, right? So that is Elon Musk autonomous car, or you can call it self-driving car. Okay, can someone tell me what he or she is observing? Can someone do that?
Yes, sir.
yes, sir.
So what can you observe?
So what can you observe?
It's moving
It's
itself
moving.
without human intervention.
Okay, so if you look at it very well,
So if you look at it very well,
you can meet yourself.
you can meet yourself.
You can see that
You can see that
the driver is not
the driver is not.
the one driving the car, but the car is driving itself. So that's why it is called self-driving cars. And artificial intelligence plays a major role in that. Okay, now we are going to look at the role of artificial intelligence in this. But before we look at how AI come into a system, because the main reason why I am here is that I will explain AI in what autonomous driving. But I wanted to take note of this. We have six level of autonomous driving, which include L0 to L5. For L0, no automation. Don't forget that we have already discussed about Industry 4.0. That is, we are combining automation with intelligence. Okay? So in this L0, we have no automation. L1, driver assistance. L2, partial automation. L3, conditional automation. L4, high automation. And lastly, L5 is what? Full automation. That is, no human driver. Though there are some like L4. In L4, you can there can be passenger and there can still be autonomous driving, because there are some people that like driving. So in that case, maybe if you want to drive, you drive. Then if you want to make it to be autonomous, you turn it to be autonomous. So let's take it again. L0, L1, L2, L3, L4, and L5. So what are the hardware components of self-driving car? Because don't let me tell you the fact. you can also what do the experiment, and Osplik will be presenting a tutorial on that. So what you need: embedded system, artificial intelligence, which have to do with machine learning, deep learning, and computer vision. Because when you look at that, you can be able to see that the computer was able to, the car was able to picture out that, okay, I need to move, then I need to stop. And before I even move on to autonomous driving, I supposed to show you the demo version of how AI works. Okay, let me show you some application that has been done, that I have done concerning that. Everybody know about snake game. We all know about what snake game, and I think we still have some phones that have that snake game, snake sensor, something like that. So actually, it's working with an aspect of AI called, because when you look at AI, we have what is called um, learning in artificial intelligence, and learning in artificial intelligence can be categorized into three. The first one is what is called supervised learning, and the second one is what is called unsupervised learning, and the third one is what is called reinforcement learning. So what do we mean by supervised learning? Supervised learning is that you give a sample data to your system, you feed in a sample data to your system, and you are able to like divide it, that okay, this is this, this is that. Let me give an instance for us to understand better. Maybe I want to work on leaf disease detection. So then the first thing is that I can take pictures of leaf that have disease. I will take them, I will snap them. After snapping them, then I will create a folder, then save those pictures. So after I've created that folder, that I've saved it, it simply means that I want to use supervised learning of artificial intelligence, creating a folder. So then I will train my system that okay, this is what is happening, that anytime you see this kind of picture, it simply means that there is what leaf disease has been detected. But if you are seeing this kind of picture of images, it simply means that no leaf detection. Let me come back again. I want to work on leaf disease detection. The first thing is that I will take images of leaf that has defect. I will save it in a folder. I will take images of leaf that doesn't have any defect. I will save it in another folder. Then I will run a machine learning algorithm, or I will run AI algorithm on it, which can be TensorFlow, Keras as deep learning. So after I've run that, then I will now test. I will now show my system another images for the system to able to like categorize if the leaf is having disease or not. Do we get it now? So anytime I'm using that approach, it simply means that I'm using supervised learning. Just like I want to train you, or just like mother to children. So you are not talking to your children that anytime you see visitor, don't take coke from him. You are giving the children warning. You are giving the children warning. As you are giving them warning, it simply shows that you are just supervising their learning. Do you understand? So that they'll be able to know that okay, this thing is not this thing is good and this thing is bad. But unsupervised learning have to do with, you don't need to segregate your data. You just supply your data to the system, and your system will be able to detect leaf disease. So that is for unsupervised learning. And for reinforcement learning have to do with, if there is a gain, then there is profit. And if there is no gain, then it's going to result to loss. So that is reinforcement learning. An example is snake sensor game. If you are playing that game, anytime you eat a pole, what will happen? The snake will what? Will die. Then you have to start the game afresh. So I want to demonstrate an example of reinforcement learning, which have to fall under the learning of AI. Okay. So people that will be joining us on tutorials, you are going to see something like this. My system wants to train the model, and just some minutes, because if you are not showing demo, we will not understand it better. So that's why we have to show this. I don't know what's happening on my system. Okay. Okay. So let me quit and restart again. Let's take note of that. So let me continue my presentation, then I will come back for the demo. Okay, so I will show the demo before I complete the presentation. Okay, now we have seen the Elon Musk Tesla car and how self-driving car looks like. That is, you don't need to drive before it move. Okay. Okay. I'm waiting for. Okay, can we all see that? So if you see, if there is a gain, then it will increase. So I have to come back. So I'm using my keyboard. Okay, so you can see. So no gain for that. So can we all see the demo version? So that's a very good example of reinforcement learning. So can I close it and go back? I believe we all see the demo version, right?
Yes, sir. Yes, sir. We can see it.
Okay, so for the hardware component of self-driving car, for us, we have looked at the component of electric vehicle. Can someone remind me the component of electric vehicle before we move on to self-driving car? Component of electric vehicle. Just give me like two.
We have body, we have motor, we have inverter, we have battery bank, we have onboard charger, and so on, sir.
Okay, okay. Thank you very much for that. Okay, now for the hardware component of self-driving car, number one is what is called GPS. GPS stands for Global Positioning System. So even on this slide, I put the price estimate of it for people that want to do the practical aspect of they want to have a simulation of their self-driving car. You can just get Arduino robotic chassis, then you can implement all these things that we have been saying for you to have a prototype of self-driving car. So the first one is GPS. So the car will have GPS to determine anomalies on the road. So that's why the GPS is coming to play that role. With GPS, you can know the location in form of the longitude and latitude of the car. Now, another one is LiDAR, which simply means light detection and ranging. So what's the meaning of that? To monitor the vehicle surrounding, the road, the vehicle, and the pedestrian. When you look at self-driving car is coming to play to solve what is called road accident. There are a lot of people that are dying as a result of road accidents, but people don't even pay attention to it. We only pay attention to malarias and the rest. But the fact is that anytime we want to travel, we all have it at the back of our mind that there is high probability of having an accident because of the Nigerian road and the rest. So, but self-driving car is coming to play the role because when you look at accidents, a lot of things can happen as a result of accident. Can people tell me what can cause accident?
Drivers are prone to drowsiness.
Good. So if the driver is sleeping, that's an error and it can lead to accident. So we have apart from drowsiness, there are a lot of things. Maybe if the road is bad. So the
Is it
car we
usual
have.
attention?
Hello. Okay, let me proceed. So we have the video cameras, as you can see it here, to monitor the vehicle surrounding. So it will be used to monitor the pedestrian also, and we have what is called the radar sensor, which is used to monitor the vehicle surroundings also in form of the road, vehicle, and pedestrian. And we have the central computer. Now, the central computer can be your microcontroller or it can be your microprocessor. An example of microprocessor is using Raspberry Pi. So it will analyze all the sensor inputs. So all the sensors that we have already deployed on this car will be connected to the central computer. Then the central computer will analyze it and give some results. And we have odometry sensor to complement and improve the GPS information. And we have the ultrasonic sensor. So ultrasonic sensor are sensor that can be used to measure the distance that can be used to measure the distance. So that is why we now need what ultrasonic sensor, maybe to check for people that are standing in front of the car, beside the car, and the rest. So these are the hardware components of self-driving car. So what are the software components of self-driving car? Number one, computer vision. That is, it should be able to for it the computer vision will be applicable for lane, pedestrian, traffic sign and indicator and collision avoidance. I don't know if you are traveling and we notice this. You can see something like um road sign. Road sign simply means it can be in form of maybe 80 kilometer. It simply means that the car should walk 80 kilometer. Then if you can see something like 20 kilometer and the rest. So all these things, the self-driving car supposed to pick all those as a result of what computer vision, because we already define computer vision as the ability of a computer to see and recognize. Now the next one is sensor fusion. So for the sensor fusion, it has to do with LiDAR, camera, radar, and ultrasonic. And the localization have to do with the what? The GPS. You know, we have discussed about that. And also prediction. The car should be able to what? Predict for what? Collision avoidance. So when you look at the demo version of what I showed you, when the car was approaching someone, it reduced the speed, then automatically it stopped. And lastly, the control theory. Okay, so what are the challenges in autonomous driving? Number one, the sensor. Night can affect it, the weather can affect it, and the traffic light can affect it. So also we have trajectory plan, the localization, the actuators, and the situation analysis and the situation prediction. So why self-driving car is essential for the future? Number one, greatly improved safety, because 94% of accidents are caused by what? Human error. But we want to make machine to be doing all this work for us. So that is where self-driving car is playing the major role. Two, improve the transport interconnectivity. Three, reduced the congestion. Four, can save time. And what are the problem of self-driving car? Number one, hacking problems. Like what we have earlier when Pakistan guy was trying to hack what is happening. So things like this can also affect what self-driving car, because there is an aspect of self-driving car called V2V, vehicle to vehicle communication. A car moving will be communicating with another cars, though we are still going to explain better during the what tutorial. And also the road system has to be what improved. So these are the what the problems or the challenges because of self-driving car. So what are the application of self-driving car? Number one, it can be applied in private as private ownership. That is, you drive comfortable and safe. Individual mobility for all. Then extended use of driving time. Number two, trucks to deliver goods. So which can be extended using of driving time, automated loading, switching, and drive safe and efficient. And lastly, cars for rent and share. Bring the car to where it is needed, bring the car back to its station. Use the best purpose car. Since you have what is called GPS, so I can program it and say, okay, maybe once the car reach here, then it should be able to what to come. to come to a particular location. Okay, so now let us look at the prominent areas in autonomous driving. This is where AI is playing the role. We have deep learning. Deep learning is playing a role on the perception. We have sensor fusion, which is playing a role on the perception as well. We have the sensor model and model predictive control, which is playing a major role in control. And we have planning, which is playing a major role in localization and planning. Okay, so in self-driving car, we need to understand machine learning and deep learning. So machine learning task using feature extracted manually from data, but deep learning is used to enhance the machine learning model. Okay, so now another thing that we need to, these are the models that we need to understand before you can work on self-driving car: machine learning and deep learning. Then you need to understand an aspect of deep learning called convolutional neural network, or called CNN. So we can use this to train our model for self-driving cars. Do you understand? Okay, now these are deep learning workflow. The first one is to access and explore the data. Then the label and pre-process data. Now, what do you mean by access and exploit data? That is, you get your data. Like, I can get data of road that are good. I can get data of roads that are not good. I will get all those data, then store it in a particular folder. That is aspect of what? Access and exploit data. I'm just trying to give you a roadmap on how to have your own self-driving cars. So the next one is now label and what? Preprocess the data. The label and process data simply means that you are not separating it by folder. That is, road is bad, road is good. You just create a folder for that. Let me show an example. Okay, now you can look at this one. This one is another AI based project. Check the data set. You can see what ahead. What I am doing now is I'm trying to what? Preprocess the data. I splitted some, like I have the test data, then I have the train data. So you can see how I splitted it in each folder. You can see how I splitted in it each folder. So this is what we are, you should be doing if you want to work on it. Now the next one is now select the network architecture. That is the architecture you want to use. I'm using deep learning. Then there are different architecture that you can use. You can use PyTorch, you can use TensorFlow and Keras. Do you get it? So you select the one that you want to work with. Then the next one is now what? Perform the training. So you can perform the training using CPU, you can perform the training using GPU. Just that if you are performing the training on GPU, it will be more faster than performing the training on CPU. Because GPU stands for graphical processing unit and CPU stands for central processing unit. And lastly, share and deploy. After you have tested your model is working and is giving you a better accuracy, then you deploy it on the hardware. So once you deploy it, you can deploy on C++ like Arduino. Then you can deploy on NVIDIA. You can deploy on Raspberry Pi if you are using Python programming language. So that is that about that. So these are the things that you need to understand as well when working on self-driving car, what is called semantic segmentation. For those that will join our AI class, we are still going to explain better about this and how to go about it. So we have what is called panoptic segmentation. And if you look at this panoptic segmentation, you can see how the input data look like. This is a data called binary image, that is black and white. Then you can see how things, a lot of filters have been applied to it. A lot of filters. So we have semantic, instant segmentation for you to now have. So this is how the computer will see it. We'll be able to differentiate that this is car. So we can see this is our input image. Then this is what our final result. Panoptic segmentation. Okay. This is also panoptic segmentation, and you can see how this thing has been labeled. We can see something like a bounding box labeling this, that this is a car, this is car, this is car, and so on. So that is that about that. So for the component of self-driving car, we can now decide on three things: sense,